In this video, you will learn about prime and composite numbers. Before we get into prime and composite numbers, you first must understand what a factor is. So a factor, by definition, are integers that multiply together to get a product. For example, if you're told to find the factors of 15, the factors of 15 are things that would multiply together to get 15. So for example, 3 and 5 are factors of 15 because 3 times 5 is 15. Alright, and technically 1 and 15 would also be factors of 15 because 1 times 15 would equal 15 as well. Another definition of factors are integers that divide a given integer with no remainder. For example, 4 is a factor of 20 because 4 divides into 20 with no remainder. Right? 20 divided by 4 equals 5, and there's no remainder left over. So 4 is a factor of 20. So the question is 5 a factor of 30? And the answer is yes, because if I divide 30 by 5, I get 6 with no remainder. So here is another example. Is 6 a factor of 30? And the answer is yes, because 30 divided by 6 equals 5 with no remainder. Now, is 7 a factor of 30? The answer is no, because 7 does not divide into 30 evenly. If I take 30 divided by 7, there's a remainder of 2. So because it does not divide evenly, 7 is not a factor. If you're told to find or list all the factors of a particular number, for example, list all the factors of 30, what I do is I see what numbers will multiply evenly together to get 30. For example, 1 times 30 equals 30. So 1 and 30 both are factors because they multiply to get 30. 2 and 15 would be factors because 2 times 15 equals 30. So we have 2 and 15 as well. And then we keep thinking through, okay, what else would multiply to get 30? Well, 3 times 10 would also equal 30. So that means 3 and 10 are also factors of 30. 5 times 6 equals 30. So 5 and 6 would also be factors of 30. So all the factors of 30 are seen here on the left. We have 1, 2, 3, 5, 6, 10, 15, and 30. Those are all the factors of 30. Now, as you try to determine the factors of a number, sometimes a number might be quite large. All right, for example, if you had the number 400 or 682, trying to think through all of the numbers that would multiply to get those larger numbers might be difficult. So here are some tests you can do to see which numbers can I multiply together. So like for example, if you had like 462 and you want to know, can I have 2 times something to get 462? You'd have to ask, okay, 462 divided by 2. Does that work evenly? And it would be yes, because 2 times 231 gives you 462. But the question is, how do I know just by looking at this that 2 would divide evenly into 462? And how do I know if 3 would or would not, or 4 or 5? So in the following slide, you will see a bunch of different tests for all these different numbers to determine if a particular number can divide evenly into a larger number. So here's the table. Let me walk you through what we have here. So on the left, we see the first number 2. So if you're trying to determine, can you divide something by 2, the rule is if the number ends in an even digit. That includes 0. So like 0, 2, 4, 6, 8. If the last digit is even, then the whole number can be divided by 2. For example, 22, you can divide by 2 because the last digit is a 2, and that divides, and that is even. So therefore, you can divide the whole number by 2. 318, the last number is an 8, which is even, so the whole thing can be divided by 2. Same thing with 5,786. The last number is a 6, which is even, so therefore, yes, you can divide by 2. Looking at 3, if you're trying to determine, can I divide a number by 3, what you can do is you can add the digits together. So for example, 81, you add the 8 plus 1, which is 9. If this number 9 you can divide by 3 and it works out evenly, then we know, yes, the entire number 81 can be divided by 3 as well. So we see 810 for the next one. If I take 8 plus 1 plus 0, just add the digits together, does that sum, can you divide that sum by 3? And yes, you can. So therefore, the entire number 810 can be divided by 3 as well. And then you see 2,370. If I add all those numbers together, 2 plus 3 plus 7, that equals 12, which can be divided by 3. So that would mean that the entire number can be divided by 3 as well. Looking at 4, the rule is if the last 2 digits of the number are divisible by 4. If that is true, then the whole number can be divided by 4. So we see here 932 ends in 32. You can divide 32 by 4 to get 8, so therefore the whole thing can be divided by 4 as well. The next number, we see an 80 at the end, so 80 can be divided by 4 to get 20, so therefore the entire number can be divided by 4 as well. To determine if a number can be divided by 5, we look to see if the entire number ends in a 0 or a 5. So 30 ends in a 0, therefore you can divide by 5 with no remainder. 920 ends in a 0, so I can divide by 5 with no remainder as well. 8,655, that ends in a 5, so therefore I can divide by 5 with no remainder. Now looking at the number 6, the rule is if the integer is divisible by 2 and 3, then the number can be divided by 6 as well. So 96, for example, you can divide by 2 because that is an even number. And you can also divide by 3 because the 9 and the 6, you add those together, that 15 you can divide by 3 and it works evenly. So you can divide by 2 and 3, therefore you can divide by 6 as well. 570. You can divide by 2 because it ends in an even number. You can divide by 3 because if you add the digits, 5 plus 7 plus 0, that gives me 12, which can be divided by 3 with no remainder. So therefore, because I can divide by 2 and 3, the entire number can be divided by 6 as well. And then same thing with 3,432. Number 9 is similar to the number 3. So the rule to determine if you can divide a number by 9 is you add the digits. So for 72, you add 7 plus 2, and you determine if that can be divided by 9 evenly. In this case, yes, it can. So therefore, the entire number 72 can be divided by 9 as well. Looking at 657, you add those digits together, 6 plus 5 plus 7, that gives me 18. That can be divided by 9 with no remainder. So therefore the entire number, 657, can be divided by 9 as well. And then 7,893, same thing. If you add those digits together, we're going to get 27, which can be divided by 3 with no remainder. So therefore the entire number can be divided by 9 as well. 10 is very easy. If the number ends in a 0, then you can divide by 10. So 80, 900, and 6,540 all end in 0, so I can divide by 10 with no remainder. Number 11 if you're dividing by 11, this one is, you can sometimes pick up on it, sometimes cannot. But with 3-digit numbers, if you notice that the first and last number add up to be the middle number, then you can divide by 11. So like the 2 and the 5 add up to be 7, so therefore 275 can be divided by 11. Same thing with 561, 5 plus 1 gives me 6, which was the middle number. 792, 7 plus 2 is 9, which adds to be the middle number. And 682, 6 plus 2 is 8, which equals the middle number. Therefore, you can divide the entire thing by 11. So now, using our definitions of factors, we can use that to determine the difference between what are called prime and composite numbers. So a prime number is a number greater than 1 that has exactly 2 positive factors. The factors would be 1 and itself. So here we see a bunch of examples. So 2, 3, 5, 7, 11, 13, etc. Notice the only thing you can divide any of these numbers by is 1 in itself. Take 13 for example. So if you try to determine what times what equals 13, the only thing that you can get, unless you have fractions, would be 1 times 13. Same thing with 17. The only way to get 17 is taking 1 times itself. So for all of these numbers, these would be prime because the only factors are 1 and itself. And take note, by the way, that it starts at the number 2. So 1 is not included. All right, so we start at 2 and go up from there. Composite numbers are numbers that are not prime. So for example, 4, 6, 8, 9, 10, 12, 14, etc. Taking 6 for example. 6, you could have 1 times 6, just like the prime numbers. But in addition to that, you could also have 2 times 3. So because we have something other than 1 times itself, we also have the 2 times 3, that gives me 6. These numbers are called composite. And composite, by the way, comes from the word compose, which means to be made up of something. So these numbers are made up of other numbers. So the 6 is made up of a 2 and a 3, 2 times 3. So therefore, those are composite numbers.